Hi everyone, today we're going to be looking at the Productivity Suite PLC Simulator software, free download. Now, detailed information contained in the video can be found at accautomation.ca. The link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in this series as well. Now, the Productivity Suite now has a PLC simulator. This will allow you to test or troubleshoot your program without the physical hardware present. And the entire family of controllers can use a simulator. That being the P1000, P2000 and P3000 simulator PLC systems. So that encompasses the entire productivity series of PLCs. Now, the emulation can happen on the following parts of the productivity series hardware. The P1000 CPUs and local I/O stack, P2000 and P3000 CPUs and local bases. And all basic I/O modules, both analog and digital, are covered, as well as the Modbus TCP server client connections, or master slave, on an external Ethernet port from your computer. Now, the simulation mode is available on the Productivity Suite version 3.8 or higher, and we'll be discussing the PAC or PAC PLC simulator, and we'll test the simulator using our first program in our Productivity 1000 series, as well as we'll look at one of the latest programs that we've done in this series later on. So let's get started, and up on my screen you'll see that we have our original program, our first program, which was the start-stop motor circuit. And our Productivity Suite programming software is version 3.80. And so what we'll do is, the first thing we'll do is check on our setup, and under hardware configuration we will take a look at that, and we see we have put in our program here. We have our power supply, we have our P1540 PLC, we have our output card, we have our combination in and out, 8 in, 8 out, and we have our simulator card, as well as we have a thermocouple card connected, which is our analog input. So let's just close that down. And you'll see here that this is the start-stop circuit that we did. We're complete with the drawing and labeling. And the first thing we'll do is we will actually connect to our simulator. Now, we can do simulator right here and connect, or we can do CPU simulator. And what that will do is actually call up our simulator. Now, it gives you a warning saying that we need to transfer the program from the software to the simulator. So it's best to think of this as a separate identity altogether. So on your computer you have a PLC that you must transfer information back and forth and read it, just like you would a regular PLC if the hardware was present. So we'll say OK, and then we can hit transfer here on the icon, or we'll go File, the transfer project to the CPU. Again, think of this as a separate identity altogether. So it transfers the project over now to the simulator, and now the simulator is running and we are online. We can see that. We are in stop mode right now. You can also see it down here. We have our task, which is our start-stop motor. We have our CPU, which is our simulator. And everything's saved, everything's up to date, and runtime transfer is available. Now, if we want to see what's happening, we'll hit the monitor here, and you can see it just looks like we are online to that controller right now. So how do we actually control our I/O? We do this through our data view. Now, last time when we used data view, we hit the rung, right click on it, and you will see monitor and data view. Now, we've already done that, and if we call up our data view here, you will actually see that we have our rung here, which is a start-stop motor. And over here at the right-hand side, we have a toggle I/O view. So if we hit the toggle I/O view, it calls up our I/O view. We click on this to expand that, and again, you will see the exact same hardware that we just discussed, which is the P1540. We have our output card, we have our combination in and out, and we have our simulator card with the I/O. Move that over there. And then we have our thermocouple card. And again, we can make that larger or smaller, and you can see the different options here. So I'm just going to reduce that down a little bit so we can see our total view here. And what you'll see is on the simulator, you'll see start, which represents this start switch right here. If I hit that, you see that highlights now, so it indicates that we are actually communicating to our simulator. If we untouch it, it turns it off. Again, similarly, because we are in stop mode, if we hit our output, we turn the output on, we can turn the output on, turn it off. So again, we can simulate all of our I/O and ring them all out to make sure that everything's working fine. Then we can put it into run mode. And again, just like the regular PLC, it will ask me if I really want to put in run mode. I'll say yes. Now my program is running. And so if I hit the start switch, then you see the motor automatically comes on. And you can see it here in my ladder diagram. And if I hit the stop, it now turns off, and then I can start it again. So very easy to simulate your project on without actually having any hardware or any investment at all, and you can give you a great head start at doing your projects. So let's just go ahead and we will close that down, and we will stop our CPU, our simulator. We'll go offline now, and now let's call up another project, and we'll open a PID instruction. And now the simulator itself does not support PID instruction itself. However, it does support the analog that comes in and out of the PID in our case. And so because of that, what we'll do is actually use that. So the first thing we'll do again is we will we have our system here. Again, we can take a look at the hardware, and our hardware is the same as what we had before. So let's go online with the simulator. So hit simulation. Again, it comes up with a warning. We'll say okay, we're going to transfer that. We'll transfer that over to our simulator. And once it's transferred over, we can hit monitor, and now we're monitoring our program. And let's just turn it into run mode as well. There we go. So once we're in run mode, then again, before we called up our data view, and we'll take a look at our hardware. There we go. And so our hardware is now running, and we are controlling this unit itself. So let's take a look at actually our PID, and let's see if I'm just going to move this over, and you'll see that we can move windows around for us. You can see we have switch number 1, which will enable our PID, and then we have switch 1 that controls our output here. So switch 1 must be on in order for our PID to actually function correctly. So what we'll do is just turn that on. There we go. And you'll also notice that if our PID output is greater than 0, then our output will start pulsing accordingly. So that's part of our nature of the PID that we did. So let's put that at about 50%, which is about 32,000. And again, I have full access because I'm online with this PLC to actually change and look at different items. So let's just write that or send that edit in. And there we go. It now is sent in, and you'll see that our output is not functioning at all. And the function is not functioning even though we're in run mode is probably because of our forcible tags, which is located right here. Now in this version of our simulator, any forcible tag cannot be used, and you must turn off that forcible tag in order for the simulator to actually work with that unit. So let's just go ahead and do that. What we'll do is go to our tag database. We will go to our discrete outputs and we'll look at our forcible, and what we'll do is actually turn those off. We'll turn them all off, all the outputs off for forcible. Then what we'll do is just save that project, and we will transfer the project, and we'll do a stop mode transfer because we're doing the database. Okay. And we're back in run mode again. This time what we'll do is, again, we will turn switch number 1 is still on. Let's take a look at our again, forcible tags. We only have inputs, so we're fine for the simulator. And our PID, we'll change this to 32,000 again. And now you'll see that my output right here is now oscillating. So again, forcible tags cannot be used in this version of our simulator. Now, the simulator itself, if it comes into instructions that will not work, then again, all the peripheral stuff around it still could be used. Let's move that down a little bit. Let's take a look at our actual PID instruction that we have. And you can see here that we have our process variable coming in this first thermocouple input. So let's take a look at that thermocouple input, which is located right here. And what I can do is actually increase that. And what you'll see is that it will actually put the same value into that register in our simulator. So very nice feature, and it's great. Okay. So there is a 2-hour time limit for this simulator. So after 2 hours, the simulator will turn off, so you must then restart the simulator once again. Now, once you have your program troubleshot and everything looks good, then what we can do is let's just stop this. Right. So we'll just close this down, and we'll now go offline. We know we have a good project. We'll save everything. And now if you look at the going online, it automatically connects to your simulator. So it automatically refers to the last mode that you're in. So in order to actually connect to the actual physical hardware, what we'll do is, the first thing we'll do is connect our CPU back into our system. And this is our physical hardware, so this is the same setup as we did with our configuration. Next, what we do is we'll choose our CPU, and it automatically comes up and discovers this one. So we'll connect to it. And no, we'll use the PC project right now, and we will do a transfer. We'll do a stop mode transfer. So now I'm actually physically moving our program into the hardware. There we go. And again, we can turn on our monitoring and switch 1, switch 2, And again, you can see my thermocouple here. So the simulator works well, and it's going to save a lot of time and effort, as well as allows you to troubleshoot those programs before you actually get on site and actually download. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. If you want more information about us, or you want our free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click that bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.